Hello, my name is Isabella Rios, and I'm with the UTA Earth and Environmental Science Department. Today, I'm going to be covering some waterborne chemical exposure risks in different communities across North Texas. So to put it simply, our aim is to quantify pollutants in water sources across the DFW area to determine if marginalized groups are more at risk than others, and why that is. We're focusing on the bad to hopefully do some good. In this study, our enemies are persistent organic pollutants, also known as POPs. And the two we're focusing on are polycyclic aromatic hydrocarbons and polychlorinated bisphenols. And then we're also throwing microplastics in there because they're kind of related. If you see microplastics, you'll see these persistent organic pollutants. So our study is set in the DFW area, and the samples were collected in a spot grab manner, meaning we just kind of scooped up the water, but a bit more professionally. Water was sourced from wells, taps, creeks, and rivers, and they were sourced in what we're defining as 3 different regions: environmental waters in DFW, a neighborhood with limited water infrastructure and informal housing, and then historically marginalized communities. So that's how we're divvying up our samples. With these samples, we performed liquid-liquid extraction to extract PAHs and PCBs. And then with those samples we extract, we use a silica gel column to clear out any unwanted stragglers and kind of narrow down our solution. For microplastics, we use microfiltration, and we use biodigestion as necessary to eliminate any organic compounds. To identify and quantify our target analytes, we used gas chromatography mass spectrometry, which is GCMS. And then we also use pyrolysis GCMS for microplastics. Our results showed that none of the samples exceeded EPA drinking water guidelines, which is good, but there's still some concerning trends in our data. So the PAHs detected in the neighborhood with limited water infrastructure is a magnitude higher than the environmental waters. However, the environmental waters displayed a much larger variety in PAHs. So we're getting a variety based on the location and the sources of these pollutants. Microplastics also warrant some concern. There is a similar trend in the sense that the environmental area is experiencing they are getting different compounds, different polymers. But the biggest concern that we're seeing is they're being detected at a level comparable to PAHs, which PAHs are regulated, microplastics are not. So we don't really understand the threats that could have. And then with PCBs, we experienced some troubles, but from what we gathered, 21 of the PCBs that we looked at are detectable in all of the samples. So they're there. We just need to quantify them. And based on our work in the literature I looked at, we're seeing some similar trends in the sense that PAHs, PCBs, and microplastics all share this in common, that they vary based on the location and the source they're from, and then that this can poorly affect marginalized groups if they're close to a construction site or close to an industrial area. These are kind of the trends we're seeing. But for further work, what we want to do is look at disinfection byproducts. So we want to add in another compound to the mix that also poses a threat to human health. And then we want to clean up our PCB methods so we can quantify those. And we also want to take a look at different sites and add in more sources of water. So I'd really like to add in pool water and splash parks, or we could look at water from waste treatment facilities. So that's what we're looking at. Yes, and this presentation was brought to you by the UTA Undergraduate Research Fund. So thank you very much for that, and yes, thank you for listening.